Okay, I'm going to cover sections 4.4 and 4.5 kind of together. The main topic here is zeros of polynomial functions. We'll look at some theorems in the next video. If f is a function, if f is a polynomial function and k is a number for which f of k equals 0, then k is called the 0 of f, or root of f, some books say. If k is a 0 of f, then x minus k is a factor of f. Okay, so in my first example, check if k equals 2 and k equals -5 are zeros of f of x. Well, I basically need to plug in 2 and -5 and see if I get 0. And so, well, let me do that. If k is 2, then 2 squared is 8. 2 cubed is 8, plus 2 squared is 12, plus minus 17 times 2 is 34. So I get -22, plus 15 is 7. -7. No, I don't get a 0 out of f. And so f of 2 is equal to -7. No, that's not a 0. How about f of -5? Okay, so -5 cubed is -125 plus -5 squared is 25. That gives me -100 plus 85. 17 times 5 is 85. -85 plus 15 is 0. Okay, so -5 is a 0 of f, and so therefore I would conclude that x minus -5 or x plus 5 is a factor of f. Using this statement right here, if k is a 0 of f, then x minus k is a factor of f. Okay, and I would also conclude that x minus 2 is not a factor of f. Okay, and another example, let's find a polynomial of degree 3 whose zeros are -1, 1, and 3. So knowing that I got a 0 means that I know I've got a factor. X plus 1 times x minus 1 times x minus 3 are factors. X plus 1 times x minus 1 gives me x squared minus 1 times x minus 3. That gives me x cubed minus 3x squared minus x plus 3. Okay, and that's one answer that I could give. Another answer could be if I have 5 as a multiplier, then I basically got 5 times these 3 factors, so I multiply each of these 4 terms by 5. 5x cubed minus 15x squared minus 5x plus 15. In fact, any polynomial of the form where I've got the 3 zeros, and then a, where a is a real number, and a is not 0, okay, because remember the 0 polynomial is the only polynomial that has no degree to it. Suppose that, so actually, for this particular problem, there's actually infinitely many answers, although most would probably give one where a is 1, okay? Suppose that f of 2 is equal to 6. Well, f of 2 means that I got to plug in 2 where I see x, and a times 2 plus 1 times 2 minus 1 times 2 minus 3 gives me a times 3 times 1 times -1, or -3a equals 6. That means that a is -2. Okay, so the answer, -2 times x plus 1 times x minus 1 times x minus 3 is the one and only answer for that. Okay, if a factor occurs more than once, the 0 is referred to as a 0 of multiplicity. For example, suppose f of x is 3 times x plus 4, x minus 4 times x plus 1 squared times x minus 2 to the 4th. Let's identify the zeros. Well, 4 is a zero of multiplicity 1, since this factor occurs only one time. X minus negative 1, or x plus 1, negative 1 is a zero with multiplicity 2. And x minus 2 is a zero of multiplicity 4. So all I'm doing is I'm looking at the zero and then the power of the factor to get the zero of multiplicity. Notice that 3 has nothing to do with anything that I'm doing with identifying a zero of multiplicity. Note that this would be a degree 7 polynomial. Okay, if I were to factor this out, I'd have a degree 2 times a degree 1 times a degree 4. Well, that would give me a degree 7 polynomial, and so ultimately I would have 7 zeros, not 3, although 3 would repeat. Okay, I'd still have these same 3 zeros, it'd just be where I'd repeat. Okay, so 1 is going to repeat twice, 2 is going to repeat 4 times, and 4 is going to repeat once. Okay, another example, find all the zeros. F of x equals 3 times x minus 1 squared times 2x plus 5. Well, 3 is, like I was saying up here, that has nothing to do with anything. That's just a coefficient. That's going to be divided throughout. So I would set x minus 1 squared equal to 0 and 2x plus 5 equals 0. X minus 1 equals 0 means that x equals 1, and then 2x plus 5 equals 0 means that x is equal to negative 5 halves. 1 is a zero that has multiplicity 2 because the factor occurs twice. So in all, I've got 3 zeros, not 2 of them. I got 3 of them. Okay. Let's take a look at this one here. For example, g of x equals x cubed minus 2x squared minus 9x plus 18. Well, I'd set g equal to 0. And now this one's going to factor nicely because I can use factor by grouping method. X squared can come out of the first 2 terms. A minus 9 can come out of the last 2 terms. X minus 2 is in common to the 2 terms there. So x minus 2 can come out in front. That would leave me with x squared minus 9 equal to 0. X equals 2 and x squared equals 9 means that x is equal to plus or minus 3. Okay, so something to note here is that I've got 3 zeros. Notice that I've got a degree 3 polynomial. Okay, there's a connection going on there, and well, let's take a look at the next one here. H of x is equal to x to the 4th plus 4x squared minus 45. Okay, I set h equal to 0 because I want to find the zeros. Now this would involve a u substitution because I'd have a quadratic in form. And if u is equal to x squared, then u squared is equal to x to the 4th. U squared plus 4u minus 45 equals 0. Okay, so there's my quadratic equal to 0. And this is going to factor nicely as u minus 5 times u plus 9 equals 0. U is equal to 5 or u equals negative 9. U is equal to, or x squared is what we're calling u. X squared is equal to 5 and x squared is equal to negative 9. If x squared is equal to 5, then x is equal to plus or minus root 5, and x squared equals negative 9 means that x is equal to plus or minus 3i. Okay, so I've got 4 zeros. Root 5, negative root 5, 3i, and negative 3i. 4 zeros. Notice that I've got a degree 4 polynomial. All 4 zeros are going to be kept. Okay. Now one thing that I want you to pay attention to when you're doing these problems is where it says find all the zeros or find all the real zeros. That's different. Okay, find all the real zeros means that I will only have 2 answers here, not 4, because 3i and negative 3i are not real numbers. For example, let's factor f of x, which is equal to 2x cubed minus 3x squared minus 5x plus 6 if k equals 1 is a 0 of f. Well, knowing that that at k equals 1 is a 0 of f, and by the way, they usually don't tell me one of the answers. They're telling me one of the answers. They're telling me one of the zeros. Okay, that usually does not happen. So they're really doing us a huge favor here in this section by already giving us one of the answers. Okay, so knowing that 1 is a 0 means that x minus 1 is a factor. Okay, so I could find the other factors by synthetically dividing. 2x cubed minus 3x squared minus 5x plus 6 divided by x minus 1. 1 is the 0 of the denominator. 2, negative 3, negative 5, and 6 are the coefficients in the numerator. And so when I synthetically divide, okay, bring the 2 down. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. Negative 5 plus negative 1 is negative 6. Negative 6 times 1 is negative 6. 6 plus negative 6 is 0. By the way, it should make sense that we get 0 left over because x minus 1 is a factor. Okay? We know that from the factor theorem, which basically says that if you plug in a 0, you're going to get 0. Okay? And so x minus k is a factor. K equals 1. Okay, now what that means to us is that 2x cubed minus 3x squared minus 5x plus 6 divided by x minus 1 equals 2x squared minus x minus 6. Okay, and if I multiply both sides by x minus 1, then I've got 2x cubed minus 3x squared minus 5x plus 6. That's what I'm calling f of x, by the way. Okay, and on the right side of that, I've got x minus 1 times 2x squared minus x minus 6. Well, 2x squared minus x minus 6 is going to factor nicely as 2x plus 3 times x minus 2. So x minus 1 times 2x plus 3 times x minus 2 would be the factors. And so I've answered the question about factoring f of x. If they ask an additional part saying what are the zeros of f, that's not a difficult question. The zeros would be 1, negative 3 halves, and 2. Okay? And by the way, this is the only way that I can do the problem. The only way. Because factor by grouping does not work. Okay, I don't have a number that's in common to the two terms that to use as a group. Okay, so let's take a look at another example here. Find the zeros of x cubed plus 4x squared minus 5 if k equals 1 is a 0 of f. Okay, now here we go again. They're telling us a 0. 1 is a 0. Okay? F of 1 equals 0 means that x minus 1 is a factor. Okay? So they're already giving me one of the answers. They usually don't do that. But they're already giving me one of the answers. 1. I know I've got 3 answers because I've got a degree of 3 polynomial. So I've got to find the other 2 zeros here. Just like I had to find the other 2 zeros and this one. Okay, well, x cubed plus 4x squared minus 5 divided by x minus 1. 1 is the 0, and 1, 4, 0, and negative 5 are the factors. By the way, I want to include 0. If I don't include 0, I automatically have a wrong answer. Okay? So sometimes it'll be the fact that you'll have a polynomial that skips some terms. Okay? Whenever a polynomial skips terms, we have to have 0 in that spot. Okay? Now, by the way, before I divide, I already know the remainder is 0. Okay? Because of the remainder theorem. F of 1 equals 0. Okay? Well, f of 1 equals the remainder. The remainder is 0. Let's check it out. So bring down the 1. 1 times 1 is 1. 4 times 1 is 5. 5 times 1 is 5. 0 plus 5 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. Okay. And so that looks good. That's expected to have 0 coming out of the calculation. Okay. And now, I'm more interested in what's to the left of 0, because x cubed plus 4x squared minus 5 divided by x minus 1 is x squared plus 5x plus 5. Okay, and let me multiply both sides by x minus 1. That's, so x cubed plus 4x squared minus 5, that's what I've got to factor, is x minus 1 times x squared plus 5x plus 5, which I've got, equals 0. X equals 1 is one of the answers. X squared plus 5x plus 5 is not going to factor nicely, although I can use the quadratic formula as my next best option. Negative b is negative 5 plus or minus the square root of b squared. 5 squared is 25 minus 4 times a is 1, times c is 5, all over 2a. 2 times 1 is 2. Negative 5 plus or minus root 5 all over 2. Okay, so this function has 3 zeros. Okay, they are 1, which they told us 1 is a 0. And then these are the two numbers, negative 5 plus root 5 all over 2. Negative 5 minus root 5 all over 2. Okay, so all in all, we've got 3 zeros. 3 zeros.